Ladies and gentlemen, please welcome to panel discussion about the topic, strengthening the cybersecurity ecosystem, open source, supply chain, and active deterrence.
All right. We good? You guys hear me? Is this thing working? Oh, wow. Okay. Well, I can just yell. All right. Well, thank you all for hanging out during lunch here. We have some awesome guests. So we've got, I'm Rob Carson. I'm going to be moderating and just chiming in randomly. But my esteemed colleagues here, we'll start with next to me is Nelson. So Nelson, you want to introduce yourself a little bit? Tell us about your background.
Sure, thanks. I'm an Erlang developer in Erlang Solutions. I work with distributed, fault-tolerant, and scalable systems. Contribute a lot to open source. My main line of work is a messaging server that is open source, and also some load testing tools, and a bunch of other minor libraries. And we do work with, like with a messaging server, we work with privacy issues, for example, with security as well, and open source.
Awesome. And Thomas, my favorite Frenchman.
For now. Yes, Thomas. I'm French, like you can hear with my shitty accent. Right now, I'm developer advocate at CDIG, a cybersecurity company. I'm mainly doing advocacy about open source projects, especially Falco, a CNCF project which has been recently graduated. Before that, I was SRE for almost 10 years. I did 5 years of on-call, a week, a month for 5 years. I'm also Golang developer. You can see that. That's pretty
awesome. Cool. Well, and my background, I do the arts and crafts of cybersecurity, so I don't do anything cool like these guys. I just hold people's hands while they change their passwords for the first time and tell them it's going to be okay. But my background is Marine Corps infantry. So anyhow, let's get started with the first question here. So, and please, you guys are in here, either put in your questions on the app or just raise your hand, shout them out. Let's make this fun. Like, it's not a huge group. So I think the first one is let's talk about security of open source, like using open source technologies. How do we secure that software bill of materials? Let's talk about that a little bit.
I can start with that. Basically, I will start with a simple story. Maybe you don't know, but in the 70s, a car manufacturer, Volvo, they invented a new security system, the seat belt. And they chose, from the beginning, to open the patent, to allow anyone in the world to use it and protect their users. This idea, this decision, saved thousands of lives over the years. It worked only because the patent was open and free to use. This is why I think open source is one of the key components for security. Having something, at least, it could be free or not, but it could be cheap or not, but at least open. It's like knowledge. Knowledge, even if you share your knowledge, you will not lose it. You can share as much as you want, everything you have, everything you know. Globally, it will increase the level of security for everyone. This is the same idea that pushed some guy a few years ago for his thesis to complete his PhD to create Let's Encrypt. This is free, anyone can use it, it's open so anyone can contribute, and it increased a lot the security on the internet. This is the same idea, open source.
Okay, but so with that great, everyone can contribute, right, and can be maintained. There's challenges though with that, right? Like, how do you know when you're using open source, it's the right tool to use? Like, what would you say about that? Like, how would you validate it's appropriate?
I need to say that I love the story of the Volvo one. I'm going to steal it. Thank you. I had one more story as well of something that was shared to make open source. We all use one messaging app or another. Call it, let's give some names: WhatsApp, Signal, Slack, Facebook Messenger, Telegram. There's so many options. And at some point, the topic of privacy became like mainstream, and the Signal people, they came up with this protocol. It's my specialty. I work with messaging, so, and often I'm being asked, like, can my server be end-to-end encrypted? Has pros and cons, but to the point is that they also opened the protocol. They published the patent, everybody could use it, and this protocol that is called Signal protocol, it's divided in 2 sub-protocols. It's the same one that WhatsApp uses, for example, and that Facebook Messenger only a month or 2 months ago finally implemented after so many years. This,
You mean Mark Zuckerberg isn't checking all your messages anymore?
hopefully, but you need to update your app version, otherwise he's still like, anyway. So yeah, that's another example of when open source helps. I think that a good thing about open source is that more than one person can have a look at it. One thing that is always said in cryptography, for example, is don't invent your own thing. Like, just don't. Like, there are lots of smart people that have studied this problem in a distributed way. In science, it's usually said that whatever your science paper is needs to be verifiable and repeatable. That's the scientific method from like 400 years ago. And that's the thing about open source, that there are more eyes looking at it. And you can think of, for example, like critical components like a kernel. Like, there are plenty of eyes looking at it, unlike other kernels that only a few selected people are. And let's not even talk about bad intentions, but just simply mistakes. The chances that thousands of people in thousands of different places without a relationship to each other would make a mistake is slower, but it's never zero. It's just increasing your chances.
But where would you go, though, to when you're looking at open source projects to find the ones that where there are thousands of people looking at it versus the one where it's just, you know, me in my basement going, hey, I learned how to use Ruby. I can do this today.
Yeah, you all know this XKCD meme that, you know, there is like a massive pyramid, like the whole economy of the world is depending on this little column here that is a open source project maintained by a random guy in his garage on his free time. And like,
that was the case for OpenSSL. Maybe you remember that 2 or 3 years ago, something like that, they discovered a big CVE in OpenSSL. OpenSSL basically is a key component for security for almost all protocols for communication, SSH primarily. And they discovered a CVE in that, and big companies, really with mountains of money, asked the developer to fix it quickly because it was critical for everyone. That guy was maintaining the project by his own for years, without any money, without any concern by anyone except that day. This is exactly the real example you mentioned with XKCD.
Yeah, so we had like the good cases, like the kernel, like the Linux kernel, there is so many geniuses working on that, there is so much money invested. This is the perfect story of open source gone right. But then you have like OpenSSL, which is just as critical, and there's just one poor guy, and then the whole world is ranting on him, and then suddenly Facebook made their own fork of OpenSSL, and Microsoft make another, and I don't know who else make another, because this guy is irresponsible.
Yeah, he's a little busy.
Yeah,
I've been fixing his hair or something.
Pay him.
Yeah, pay him. Wouldn't that be? It's a fabulous idea, right? Well, how do you? So you know, let's talk about like software bill of materials and that security supply chain. Like, where would you guys give advice, or what are the pros and cons of, you know, open source supply chain, and what are some of the cons? Like, what are the challenges you think, or are there any cons? Is it all open source? That's the way to go. Freedom.
First, we have to define what is SBOM, software bill of material. Everyone among the attendees knows what's SBOM or not. Basically, the idea behind is just to list all the dependencies of your project. So, and the dependencies of the dependencies, and the dependencies, and so on.
Do you know where that came from? Drugs. From the FDA.
Yeah.
Bill of materials. Like, it's like you get your initial precursors, all your drugs they put together. That's actually where a lot of that originated.
I was told it came from construction. And, like,
you
know, the bolts and drives that you use.
I thought it came for meat. To be sure.
Well, we've all got different rumors of. The point is like it came from highly regulated industries where you needed to know where did this chemical come from, where did everything come from, or
like by the molecule level, everything is documented exactly.
You want to talk about compliance? That's a whole other level.
But it works only if every layers in the chain plays the game correctly. So it's not really easy to do so. This is why I think SBOM right now it's nice, but not really useful.
Okay.
Because we love containers, I think. Most people love containers. But for
You love what?
the containers, Dockers and
Docker
so on.
containers.
Containers.
Sorry.
French accent. Love containers.
I was like, we love whatever it is, man.
No, but to be honest, most of them are just black boxes.
Mm-hmm.
We don't know what we are running. SBOM is one of the solutions to have at least a better idea of what is running inside a container.
Mm-hmm.
But you have just an idea of the supposed to be inside applications and packages. But when you build your images, you don't know if the compilation, if the build process has been correctly made, and if nothing has been introduced illegally, illegally in that.
Yeah.
And this is another tricky question. This is why we also have
one great case. Yeah.
Exactly, signatures.
Yeah.
And especially we have this case with the libxz. You tell the story much better than me.
Let's hear the story. We had a great lunch discussion. Should have been here for the panel.
You all have heard
lunch.
of the Exit library vulnerability from not long ago, a couple of months. Sounds familiar, rings a bell. Just a comment on the containers. That reminds me of another joke. A programmer says it works in my computer, and the manager says, "Okay, let's ship your computer." That's containers in a nutshell. The Exit vulnerability, that was brilliant. I was very impressed. And I'm also concerned that, like, okay, we detected this one. What about the ones we didn't? Because that was very smart. So the story. Exit is library utilities for compression algorithms. So zip and slib and the usual ones. That is very popular in the distros for Linux. And it's maintained by one guy. And which project doesn't ever do compression? It's, again, we have the problem, as I said before, OpenSSL is super critical, but there is one poor guy. So in a compression, the standard compression library, again, there is one guy, and he's tired, and he has his main job and his family. And one day, a couple of years ago, a guy appears on the internet making a contribution here and there to different repos, and then he arrives to this one, makes some contribution, very good code, with good descriptions, everything super friendly. He starts joining the community. And after a couple of years, the official maintainer makes him a maintainer, because by now the guy really is the maintainer. He's like contributing all the stuff, so he just gives him access rights on GitHub. And the little community of people looking at Exit, because nobody was coding, is very happy with this decision. One day, I believe in January, more or less, there is a Postgres developer. I don't know who of you was on this talk this morning, like 9 to 5 and then fuck it. That the guy was talking that the stereotypical programmer is that one whose hobby and job are very related, and there is a little boundary between what I like to do for fun and what I get paid for, which might introduce unhealthy habits. Anyway, there is a Postgres developer that is having his own farm in his own home because he likes it. So this is the first requirement. He's not being paid for this. He is investigating some fun stuff that he did in Postgres, and something is slow. He's running on the latest x86 chips, running all the software of materials. Everything is running on the latest version, latest kernel, latest systemd, latest dependency. Everything is just compiled from master. Just testing on the edge. And something is suspiciously slow that is not supposed to be. He enters his SSH to his machines, and he realizes that it's his SSH connection what is slowing down a lot of stuff. He's like, what does this has to do with Postgres? His job again is Postgres, and again, he's not doing this at working hours with his working hardware, but his job is Postgres. He gets curious and he says, okay, I'm going to investigate OpenSSH because something is slow here. Super complicated. He realizes that, which the craziest algorithm, OpenSSH, where Postgres uses OpenSSH, OpenSSH requests systemd for compression functions. Systemd provides dynamic function pointers. This is super low level stuff. And systemd provides a pointer to this compression library, where this new guy is now the maintainer. and now this compression library executes some code. Now that guy, he made some pull requests like more than a year ago, where in tests, the tests were spawning another server and verifying the connection and the compression and so on. He used a compilation, a linking flag that systemd needs to like decide when you need to compile a low-level project for so many architectures to like simplify the whole linking thing. He uses the same trick that systemd does to dynamically inject the test into the binary as is shipped in the code. So the binary is not exactly the same source code, but verifying the binary is made hard by a very useful and popular trick that linkers give you. But you cannot get rid of this trick because then you need to get rid of systemd. And in this way, what was being slow is that he was not compressing a movie, he was compressing the keys, so this is supposed to be instant, pretty much a nanosecond. But it was taking around half a second, so this is like noticeably slower. And in this moment, he was just like stealing the keys and sending it to everyone. This guy started making a mistake when he saw that systemd make a pull request to change the way the linking works. Not because it's vulnerable, but because systemd say that the current linking mechanism is a bit hacky. We can find a cleaner way to do it. They didn't even know it was vulnerable to attacks, it was just hacky. And when the guy from XC saw that systemd is going to break how his algorithm works, he started pushing a lot of people to rush, and that's when he started calling attention as well. It's so tricky.
Yeah.
And it depends on so many different projects. This depends on, it only runs on x86. It depends on how systemd does the weird stuff, how the linker helps systemd do that. Like,
so then what would you...
there is no single person that works in all of those projects at the same time.
Absolutely. And that's where, you know, you have a nation state potentially trying to execute something like that. It's difficult, right? So what would you say for the, you know, you're on the IT team, you're trying to use some open source, you're on the dev team, you're trying to leverage these things, but you have people that are afraid of it, there are risks. What measures would you put in place that would prevent maybe some of this? You can't stop everything, right? That's impossible. I have a better chance of growing a full head of hair. It is what it is. Like, but what would you say? Like, what would you do to stop it or mitigate those risks? What's one thing you could have done?
Of course, we got the chance to have someone so passionate about the topic that he spent his own time to discover this stuff. But this was possible only because everything from A to Z was totally open. The code base was open, but also the requests from the maintainers, from the contributors, from the users.
The discussions were also public.
All discussions were public.
Everything was public.
If everything was totally hidden behind a paywall or else, I think it would be totally
undiscovered.
Missed by the community, by the users, and this wrong stuff will be integrated for sure. Especially when you are a big company and you have to make money. It's legit. You can't wait for years or for months or for weeks on a so small issue or so small changes. You can say, okay, it's just 2 lines in my code base, 2 lines in the test. Yeah. Okay, let's approve that. Let's move on because I need to integrate that feature that will make me more money after. This is why open source is important, and this is why I think open source won for a long time now. Linux is the most used system for servers, for mainframes. For mobile phones, it's Android. For security, we have OpenSSH and so on. Almost all protocols are open for that. Signal, but even the most basic ones like HTML. So this is the first thing to have. It's the ability to review, and it's thanks to open source. Then we need all the tools to prevent. It's the other part.
Yep.
We talk about SBOM just to know the tree of dependencies, but we also need to be sure we use the dependency that is noticed in the tree. So we have now things like cosign to have a signature for every package we provide, every artifact. This is another level.
Okay.
We also need to prevent bad stuff happening at the CI level. So we also need to control what the worker nodes do. For example, GitHub, I know for sure, not exactly for that, but they are using the project I'm maintaining, Falco, underlying when you run some actions in GitHub Actions. GitHub has thousands and thousands of nodes, and they are running Falco to detect suspicious behaviors. To protect GitHub, not to protect the users. But at the end, everyone is protected a little bit more. This is another level. I lost my stream of thoughts.
I think when you're a provider of a service where like you allow people to execute code in your service, that it is a Pandora box. It's like if you allow, I don't know, storage is Gmail or cloud, and you put your pictures, whatever, it's just content. But the moment you allow any user to execute code in your server, people can execute the weirdest stuff, like from hack attacks to crypto mining. I remember, in open source, it's very common that you get like free credits from distinct CI environments because it's open source and they promote it and so on. And some years ago, when the whole crypto boom started, I remember so many of our CI that we were being contacted by Travis, Circle CI, GitHub Action didn't exist back then, telling that we need to close and re-verify because suddenly a lot of CI is actually crypto mining, and like crypto miners are running crypto mining in our
AWS
offering. Yeah.
I always tell people, it's like one of your best security indicators is your spend on your AWS environment. That'll give you an indicator of, you've turned half your operation to a Bitcoin mining operation.
Yeah. Somebody's
your expenses start going up.
CPU,
you haven't done anything. You're like, why am my costs going up?
Funny things happened to Amazon last week. Maybe you noticed that. A company, they checked their bill after this, and they noticed really huge amount. And for Amazon S3, the object storage system, and they discovered 99% of these fees were related to 404 errors. So basically, on Amazon, when you try to pull an object on S3 and this object doesn't exist, you are charged anyway by Amazon. And they discovered if someone else than you try to call that object, the fees are on you. You have to pay you. And because of some conflicts between the bucket names, they discovered, for a strange reason, a lot of systems all around the world were calling their S3 bucket for missing objects, and they had to pay thousands and thousands of dollars for that. They discovered that, they complained, Amazon refunded, agreed to remove the bill for that, and they changed the behavior. So now we can't anymore do that. I think it was a nice way to annoy your neighbors. I think some did that. I'm not sure of that, but this is exactly the pattern you mentioned. Lets your users do stuff, and you will see what you. Basically, the best chaos engineering tool is basically human. So.
Like when you're back on Monday to work, check your AWS. Like just know your DevOps people to check the bills.
It's a crazy thought, right? But it's like, we got all this technology. Let's just look at the bill, right? Any questions while we're going through this here? Well, here we go. What's better? To quickly patch and disclose supply chain vulnerabilities to maintain transparency, or quietly mitigate them to avoid alerting potential attackers.
Ooh.
And this is a problem in open source because the patch that fixes the vulnerability is public. So the moment you public the patch, there is an attacker that says, this patch, it's fixing this. Let's attack it before this patch is distributed. And this is a disadvantage of open source that has always made me sad, basically.
Yeah, but the other part is even on the commercial side, it winds up being security through. I look at it. It's interesting because I have this challenge on the other side, right? And it's like, should we tell anybody about this? And it's like, well, you think you're the only one that discovered it, right?
Yeah.
So pushing the patch out. Yeah. Okay, but there's a good chance someone already found that vulnerability as well. Because the best So I deal with, you know, hardcore pen testers, people that trade no days on a regular basis, stuff like that. That's more my space. And like I can tell you, they probably already know. And it's like Eternal Blue. Like it's like, oh, only the CIA would figure that one out. Like, no, that's not exactly how that works, right? So it's a challenge, but I think it's better. I would argue it's better to get it out there because the best attackers potentially already know about it.
Yeah, like something that I have seen on the Linux kernel sometimes, like there is a disclosure that works only with selected people. They fix it, nobody knows. They publish a patch, but the description doesn't say that it's necessarily that critical or something. So a very smart attacker can like see what is it that is being fixed, but they try not to call attention at least.
Yeah, it's like Apple patches
like,
sometimes.
yeah,
it's like, it's security fixes.
Yeah, just
press update, it'll be fine.
But yeah, the thing on Apple, for example, is well, Apple's kernel is public, but it's open source, but the rest of the system is not. So sometimes that's an advantage when you don't know the code, you don't know that a patch is being fixed. But again, that's security through, how do you call it?
Security through obscurity.
Through obscurity. That's not really,
Yeah. No,
not the best security.
And it's one of those like own it, fix it, move on, as opposed to. I mean, I would argue that all day long because like it's good to. Well, the question is, and that's the thing is like developing the patch. It's one thing though. You could argue, is it worth pushing out if there's a vulnerability but you don't have a fix yet, right?
Yeah.
Like that might be the time where you're not disclosing it because you're trying to figure out what the mitigation effect is. Then push out the solution with it. At least then you can go. You give somebody. It's not, hey, you're screwed. We'll let you know in a week when we have a fix. Okay, you're screwed, and here's your fix. Because otherwise, you're just sitting there going.
You know, that reminds me of.
That's a good question. Though. Like, you leave it open.
This, what was the name? This CPU vulnerabilities that was a big deal a few years ago. The Spectre.
Mm-hmm.
That was disclosed to Intel, and Intel was like mind blown. And the disclosure that was done the proper way, it was disclosed in secret, and you have like so much time, and Intel had no idea what to do with that. The expiracy happened, and then they said that there is a 0-day vulnerability in the CPU, but they still didn't say what was it. But they were very responsible. That was a really big deal. That was a crisis. The whole world got like 10% slower having to fix that.
It was really harder to fix because it's material, it's physical.
Yeah.
So you can't change a CPU like you change just some lines of code. Even if at the end they replace some microcode of the CPU, but it decreased the performances. It created so much latencies. People were impacted a lot because of that.
I want to mention something, a little bit of an anecdote. Before being an Erlang developer, I was working in C a lot, and you have the use of performance, compiled languages versus interpreted languages, and a compile is. I have a myth-breaking line for you. All languages are interpreted. C is also interpreted. The assembly is reinterpreted on the CPU. The CPU has a virtual machine executing the x86 code. The last time the CPU, the x86 was not interpreted was, I believe, Pentium 1 or Pentium 2. I'm not sure which one, if it was Pentium 2 or Pentium 3. They wanted to introduce optimizations to the CPU, but they couldn't do it without breaking the binary instructions and breaking like all that is compiled in the world. So the CPU has a virtual machine inside. Like C is also interpreted. Of course, it's a different layer of interpretation. So there are fixes in the CPU that you can do because it really is a virtual machine. That's a microcode that you hear about.
Hope everyone understood all that. That was awesome.
But
so like some next
just
level.
to complete the answer to this question, as an open source maintainer, transparency is really, really important for us.
You lose you lose the purpose of open source without it, right?
Yeah, exactly, totally. If you try to add something to your users, to contributors, maintainers, or else, it's really easy to lose the confidence. So it's better to patch quickly and communicate, because even if you hide the stuff, you are sure even after years, a lot of systems still have the CVE because people are not patching their
well, I push all the time for companies. I'm like, I don't care how many vulnerabilities, I care how old they are.
Yeah.
Like, because that's what it really comes down to. It's like, did you fix it in time? Because like, you think about the rapid, this vulnerability has been exposed for a week. There's been stuff that's out there for years that people are still haven't fixed. So
Log4j is an example.
Yeah.
Another big deal you all have heard probably, Log4j, Java, Logger, zero-day vulnerability, world went mad. There was a study from Maven Central, which is where you get like all the dependencies, that last year in 2023, 25% of the downloads of Log4j were still of all vulnerable versions. So there is still a lot of code that is just like recompiling or whatever, running on CI, is automated, that has not been upgraded, is still fetching vulnerable version. 25% of all the downloads during 2023.
Yeah.
And it's already a more than 2 years old vulnerability.
The good part is we're all going to be in business. So I guess one of the questions we got here is, what are your favorite tools for monitoring vulnerabilities and dependencies on projects using different languages? So we'll start with Thomas. Give us your top two.
Trivy is pretty famous for that.
Which one?
Trivy from Aqua Security. It's basically it scans images. I'm not doing production anymore, so for 3 years now. I don't have any favorite tools. As long as you have tools you can use and you understand the report, it's a good. It's
probably
tool.
The best answer is the one tool you're actually going to use.
Yeah, exactly. Because we have plenty of tools, but if you just run them without any actions after, it's totally useless. Security is not an action; it's a process.
Yeah, it's funny. I've seen tools that they're great, but they don't integrate into the pipeline or to the. They don't create the request to fix stuff, and
you need the human resources to take care of that after.
Absolutely. What about yourself?
Most of my programming is in Erlang, which I'm going to brag about the fact that we have one of the lowest rates of CVEs in the top 100 programming languages in the world.
Okay.
Like we are like top one in the bottom.
Okay.
So I'm very proud of that. We have very little, so little to monitor. So usually, like, as there is so little, you just get the official CVEs and they are usually fixed.
Okay. Do you find though that sometimes they wind up being overweighted, where you get, like a lot of times, like on my side, I see like two mediums is actually a high if I combine them together. Like, do you guys run across that, where you're like, oh, this should be weighted lower, weighted higher? Because sometimes the CVE scores, like or CVSS, they wind up showing it's a high availability issue, but availability is not the issue, right?
Another interesting tool is not really to get the vulnerabilities, is to be sure you are up to date. For example, if you are using GitHub, for free you can use Dependabot, which is a bot in charge to check all your dependencies and propose to you through PRs upgrades for the dependencies. It's pretty convenient and it avoids you to think about that annoying step to upgrade everything.
Awesome.
Another food for thought that I was thinking, statistics, I like checking them. Popularity is not correlated to maintainability. And one example we have already mentioned a few, OpenSSL or XZ, they are like absolutely popular. Every single Linux distro has them, more or less every single one, but they are heavily unmaintained. So that's something to pay attention to when checking tools you're using.
We got a new question here. This is a good one. What's more effective for securing open source projects? Regular code audits by security firms or the community?
All of it.
See, that would be my answer. It's like, I want both. I don't trust anyone.
Basically, I will explain. Falco, the project I'm maintaining, is a graduated project as a CNCF. To get the graduation, even to get the level of incubation, we have to do these two things. First, we have to do regular community-driven reports. So basically, we have the maintainers, we have some searchers doing analysis by their own to write papers after. And once a year, we have to buy a professional, totally independent team to do a deeper or more complete audit of the code base once a year. It's mandatory to still have the graduation level. So The answer is pretty easy. Well,
Absolutely. Well, I mean, like, you remember the security firms? Those guys, this is what they do on a regular basis, so they're geared for it, and they're getting paid to find something. Like, I've got buddies that get paid a lot of money to find O-Days every single year. Like, that's their job, right? And like, there's also
the Google Zero Day team.
Yeah.
Kudos to them. Like,
I mean, that's the thing is like this is all they do. And then like, I mean, what do you think about what's it called? Like bug bounty, stuff like that. You guys ever run? You guys like? You ever use that? The bug bounty programs?
I haven't had the luck.
Yeah.
But I encourage them. I think it's smart.
bug bounties are more for companies with a product, not for a project.
Yeah.
Because you have to basically to do a bug bounty, you need data in the background, you need users and so on. Just the project itself, you have to install it, you have to do everything by your own. It's not the spirit of a bug bounty. And you also need money for the bounties.
You do.
So,
well, and then people get upset when you think like, "Oh, I'm giving you $100." Like that's $1,000 bug. Like
Apple pays a lot.
They get very upset some days, right? Cool.
It's worse when you get at one of these firms just suing you for attacking their service. Like, I was trying to help. What the hell? It's I disclose it in secret anyway.
People get upset no matter what. Any other questions here? If not, I think we'll wrap up here. We got one more here. Okay. Not really quick. Nice shoes, Rob. Right. That's right. You just have skulls on them for the record. Like,
you should have seen a shirt yesterday.
Making compliance sexy every day I can. Any other questions? These are some sweet shoes.
I preferred your shirt yesterday.
Hey man, these things though, man, like they got skulls.
You
got skulls on your shoes? No.
No.
Exactly. That's right. I'm a badass.
Totally.
Any other questions? All right. Thank you all for your time.